Hi, myself Devananda Rao, working as Associate Professor in the Department of CSC, MLR Institute of Technology, Hyderabad. Today's topic is operator grammar and construction of operator precedence table and parsing the input string. Operator precedence grammar is a kind of shift-reduce parsing method. It is applied to a small class of grammars. A grammar is said to be operator precedence grammar if it has two properties. The first one is no RHS of any production has epsilon. That means, for example, A derives epsilon is not allowed. It is not a operator grammar. And no two non-terminals are adjacent. For example, A derives B, C, D. It is not an operator grammar because two consecutive adjacent non-terminals occurring here, either B, C or C, D. Operator precedence can only establish between the terminals of the grammar. It ignores the non-terminals. So, in this, the relationship between terminals only. There is no relationship between non-terminals. There are three operator precedence relations. First one is A has more precedence than B. This symbol is not greater than symbol, don't confuse. This symbol A takes more precedence than B. A has more precedence than B. Terminal A has more precedence than terminal B. Suppose this symbol A has less precedence than B. A and B are the terminals. This symbol A and B has same precedence. Terminal A and terminal B has same precedence. These are the three precedence relations in this grammar. There is not given any relationship between ID and ID. See, identifier is anything, any variable, anything, any number. There is no relationship between identifier and identifier because no two variables occurs on the RHS of the production. So that ID will not appear adjacent. So that there is no relationship between ID and ID. Example of operator grammar. See, E derives E plus E. E derives E star E. E derives ID. This grammar is operator grammar because right hand side no epsilon, RHS no epsilon, and no two adjacent non-terminals. So, this is operator grammar. But this grammar S derives SAS or A derives BS B or B is not operator grammar because here two adjacent non-terminals occurring, two variables occurring, they are adjacent. But we can convert this grammar into operator grammar. How it is? S derives S. You can replace this A by BSB. BSB. This S is as it is, and this A by you can replace by B also. SBS or A. A derives BSB or B. This is now operator grammar because no epsilon on the RHS and no two variables are adjacent. Next, construction of operator precedence relation table for the given grammar. E derives E plus E or E star E or ID. It is expression grammar. See, we have to establish the relationship between plus and plus, plus and plus, and star and plus, and star and star, and star and identifier like that. And there is no relationship between identifier and identifier because no two variables occurring adjacent. See, between plus and plus, for example, if you take a expression 1 plus 2 plus 3, it is an expression. While we are scanning this expression, this is the first plus, this is second plus, this is left hand side plus, this is next plus. But while expression, this sub expression will be evaluated plus 1 plus 2 is 3, 3 plus 3 is 6. So, first this expression will be evaluated because plus is left associative, plus is left associative operator. So, that between plus and plus, this plus has more precedence than right hand side plus, and 1 plus 2 star 3. Between the plus and star, the relationship must be star has more precedence than plus. or plus has less precedence than star, because star is always having more precedence. Plus first 2 star 3 will be evaluated, that result will be added to 1. So that star is high precedence than plus. And also between star and star, 1 plus 1 star 2 star 3, first this expression will be evaluated, next this expression will be evaluated, 2 star 3. So that left hand side star has more precedence than star, right hand side star. Star operator is also left associate, and also identifier has more precedence than any operator, identifier has more precedence than any operator or identifier, any dollar also. And also here we will take the table having rows and columns. In rows and columns we will take the terminals only. Already I told you there is a relationship between terminals only, not between the non-terminals. The operator precedence parser will ignore the non-terminals. So ID plus star are the terminal symbols in the given grammar. Along with this star plus ID, we have to take dollar, because dollar is end marker of the input string. Here also in column also identifier plus star dollar. Now we have to show the relationship between the terminals. There is no relationship between identifier and identifier. Row identifier, row column, there is no relationship, because no two non-terminals occurring adjacent. So that there is no relationship. So write the relationship table. Between ID there is no relationship, and identifier has more precedence than any terminal or dollar or operator. So that ID has more precedence than plus, ID has more precedence than star, ID has more precedence than dollar. Come to plus. Plus has more precedence than plus, because left hand 1 plus 2 plus 3, this plus will be evaluated first. So that plus has more precedence than plus, and plus has less precedence than star, because star has more precedence. Plus has less precedence than star, and dollar always has less precedence than any symbol or any terminal, any operator. So that plus has more precedence than dollar. Plus and ID, because ID has more precedence than any operator. So that plus has less precedence than ID. Star is operator, has less precedence than identifier. Star has more precedence than plus. Star has high precedence than star, because between star and star the relationship must be, because 1 star 2 star 3, first because star is left associative, 1 into 2 will be evaluated first, that result will be evaluated with 3. So that star has more precedence than star, and star has more precedence than dollar, because always dollar has less precedence. Come to dollar. Dollar has less precedence than any operator and identifier. Dollar has less precedence than identifier, dollar has less precedence than plus, dollar has less precedence than star. Between dollar and dollar, the operation is accept. Now we will parse the string. For that we need to take stack and relation between the terminals and input operation. Initially stack is dollar, having dollar, initially stack is empty, that is dollar indicates empty stack. Input is ID plus ID star ID followed by dollar. Dollar is end marker of the input. Dollar and ID, dollar and identifier, the relation is less than relationship. Whenever any identifier operator of the input buffer has more precedence than the symbol on the stack, we can push the input symbol onto the stack, so that we can shift the identifier onto the stack ID. Remaining input is plus ID star ID dollar. Identifier plus identifier has more precedence than plus. If the symbol on the stack has more precedence than the symbol on the input, we can perform pop operation and reduce by the production. So this is ID is a handle matching with this handle matching with the right hand side of the production, that is body of the production, that is E derives ID. We can reduce this ID to E, $E, and remaining input plus ID star ID dollar. There is no relationship. The operator precedence parser ignore non-terminals, only the relationship between terminals only. Now dollar is on the top, is on the stack, and plus is the current input symbol. So that dollar and plus, between dollar and plus the relationship is less than relation. Dollar has less precedence, so that shift plus is shifted onto the stack. Now remaining input ID star ID dollar. Plus ID, plus has less precedence than ID, so that shift dollar E plus ID and star ID dollar. Plus ID, top of the stack is ID and star is great higher precedence. ID has more precedence than star, so that pop reduced by, because ID is a handle, reduced by the production, E derives ID dollar E plus E star ID dollar. Now E is non-terminal, so that we will take this plus and star, star has more precedence, so that shift dollar E plus E star ID. Star ID, star and identifier, star has less precedence than ID, so that shift dollar E plus E star ID dollar. ID has more precedence, so that pop and reduce, because ID is a handle, E derives ID dollar E plus E star E dollar. Star and dollar, star has more precedence, so that pop. We have to find the handle now. What is the handle? E star is handle, because E star is there in the given grammar, the body of the production. Now the reduction by the rule E derives E star E, E plus E dollar. Plus and dollar has more precedence. Pop reduction by E plus E is a handle, so that E derives E plus E dollar E. So E is a non-terminal. Dollar and dollar accept. String is accepted. Like that we have to parse the input string, because operator precedence relation grammar is a bottom-up parser, so that the parse tree will be constructed leaf to start node. See, the input is ID plus ID star ID. The first operation is shift, then next operation ID is reduced to E, this ID is reduced to E, next this ID is reduced to E, next ID is reduced to E. Next operation is E star E is reduced to E, E star E is reduced to E. The next operation E plus E reduced to E, E plus E is reduced to E, E plus E. So like that we can construct the parse tree. This is the operator precedence parser, parsing table, relation table. Thank you.